Hello everyone. Welcome to part 2 in our series about the derivative. Today we're going to be talking about how to calculate using the definition of the derivative. Okay, so last time we looked at the concept of the derivative and we came up with a definition. I'll write it right now because we're going to need it. It's the limit as h goes to 0 of f of x plus h minus f of x, and that's all over h. Okay, put that in a nice box. Now, how do we symbolize this definition? Most commonly we use f prime of x. This might not be the best symbol, but the idea is that we want to associate the derivative of f with the function that it came from, which is f. Even though this function may look completely different than this function. I mean, really, you can think of this as like g of x or h of x. It could be something completely different. But we symbolize it this way so that we remember, oh, okay, this is actually the derivative of another function called f. Okay, so let's use this definition to actually calculate derivatives of classic prototype functions. Okay, here we go. Our first function is f of x equals x. We kind of know the answer ahead of time. If you looked at the last video, the concept of the derivative was that it's the slope of the tangent line to a function at any point. Well, this function itself is a line. It has a constant slope of 1. Our answer for our derivative should actually be 1. Let's see if that's true. F prime of x equals limit h goes to 0. Okay, the first thing we need is, in our definition, f of x plus h. What does that mean? Remember, we need f of x plus h minus f of x. That's the thing that goes in the numerator of our derivative definition. What does this actually mean? It's actually very simple. You take, every time you see an x in our function, substitute x plus h. So instead of x here, f of x plus h is just going to be x plus h. Easy as that. Next, we subtract this function, which is simply minus x, and that's all over h, because that's our definition of the derivative. Okay, limit h goes to 0. And I know it's kind of annoying to have to write this limit thing every time, but try to make sure you do that, because it's really not correct if you don't. Now, notice this will simplify very nicely, and after a while you're going to realize that it's going to have to simplify this way. If you have any terms in the numerator without an h in it, you're going to be in trouble. In this case, notice how the x here cancels the x here. All I get is h over h. Well, that's just the limit as h goes to 0 of the number 1. Well, that's about as easy a limit as it gets. That's 1. So this is our function. This is our derivative. It's actually equal to 1. It doesn't even depend on x. That's exactly what we wanted, right? The slope of this curve, it's really a line, but the slope of this curve at any point is in fact 1. Okay, let's try a little more interesting example. Our friend the parabola, f of x equals x squared. Okay, let's go. F prime of x equals limit h goes to 0. Okay, f of x plus h, again, we substitute everywhere I see an x, I substitute x plus h. So in this case, I get x plus h quantity squared. That's f of x plus h. Minus f of x, well, that's just x squared, all over, as usual, all over h. Okay, I'm hoping that you can FOIL this out pretty easily for yourself. we're going to get limit h goes to 0, x squared plus 2hx plus h squared minus x squared, and that, as usual, all over h. Notice how x squared here cancels x squared there. Everywhere else I have an h in the terms. Each h is going to get canceled by a single power of h in the bottom, so I get limit h goes to 0 of 2hx over h, well that's just 2x, plus h squared over h, well that's just h. I'm ready to go. I'm taking the limit of this entire thing. That's another easy one. I just set h equal to 0 and I get my answer, which is 2x. That is our derivative. It's what we call f prime of x. F prime of x is equal to 2x. The slope of the tangent line on the parabola x squared is equal to 2x. So for example, if I wanted to know what is the slope of the tangent line when x equals 3, I would just plug 3 into here and my answer would be 6. Basically we have a slope function. Okay, let's do another. F of x equals x cubed. Okay, process is the same. Limit h goes to 0. F of x plus h, well that's x plus h quantity cubed, minus f of x, well that's x cubed, all over h. Okay, that's a little yuckier, but not so much. You're just going to have to FOIL this out, multiply x plus h by itself 3 times, or if you remember the binomial theorem, you're going to get x cubed plus 3x squared h plus 3xh squared plus h cubed. And it looks like I've completely run out of space, so I'm going to give myself a little more space. Okay, that whole thing here was x plus h quantity cubed. I still have to subtract off x cubed, and then I'm going to divide that whole kind of nasty mess by h. Okay, once again, x cubed here cancels x cubed here, and I can divide each one of the remaining terms by a single power of h, and I'm going to get limit h goes to 0 of 3x squared plus 3xh plus h squared. Now I can plug in h equals 0. The whole problem here was that I couldn't plug in h equals 0 originally because there was a 0 in the denominator. There's no more 0 in the denominator because this h canceled all the h's in these terms. And I get my answer, 3x squared. Okay, one more example. Square root of x. F prime of x equals limit h goes to 0. F of x plus h, square root of x plus h, minus f of x. That whole thing goes over h. We've seen this kind of issue before with a limit where I have a square root minus a square root. How do we deal with that? We multiply by what we call the conjugate, which is the same thing in the numerator, just with a plus sign. Now I have to multiply by the same thing in the denominator, so that really I'm just multiplying the whole thing by 1, which doesn't actually change anything. And this, why do we do this? It's because we get a difference of two squares. X minus y times x plus y, that's equal to this quantity squared minus this quantity squared. And I get limit h goes to 0. X plus h, that's this quantity squared, minus x, that's this quantity squared. And that whole thing is over h. Oops. And we still have this little nasty piece here. That's this part. But look what happens. X cancels this X. This H is the only thing that's left. It cancels that H. I can plug in H equals 0 in the rest of it. Look at what I get. 1 over 2 root X. This quantity becomes root X. This is also root X. I just get 2 root X. That's my derivative of the square root of X. Okay, just to quickly summarize our findings. Put these in purple. Okay, the derivative of X, that turned out to be 1. The derivative of X squared, 2X. The derivative of X cubed, 3X squared. And the derivative of X to the 1/2 was actually 1/2 X to the minus 1/2. We didn't really do this one. What's the derivative of a constant function? Basically, what is the slope of that function? It's 0. That's it. In the next video, we'll try to find a pattern for all these expressions and come up with what we call the power rule. Hope you enjoyed the video. See you next time.